Hello, my name is Munim Tahmid and this is our project ScholarAI. So in this video, I am going to guide you on how can you get started with our project. So this is the GitHub repository of our project. If you go to this repo, you can see that there are 5 repositories. All of them are public, so you can always contribute to our project. Now, this is the main repo of our project, and you can see there is a comprehensive readme file that has already guide you then how can you install and run the project on your machine. So basically, first of all, we have all these 5 repository, which is for the front end Spring Boot FastAPI, and for the docs we have we have already a demonstration video that the link of the video is on the description. You can always see the demonstration video to see what are the features that we have. So for the quick start, you'll have to follow this setup instruction. You have to set up this environment variables, and for all 3 repository, all the environment variable format is given. You have to basically put your own accounts environment variable if you want to uh, run locally. And you can also like use Docker for fast deployment. The process is very simple. You already have the Docker infrastructure ready. You just basically has to build and start, and it will automatically start the web app and all 3 repository. Also, if you don't want to use Docker, you can always do it individually and in your machine one by one. We also have all the instruction for that. For the architecture, basically front end, we are using Next.js and it is communicating with Spring Boot API using the HTTP. And our Spring Boot is communicating with our agentic framework, which is FastAPI using RabbitMQ message queue. Now, FastAPI is the house of all the agents and API and all the key uh, agent processing stuff. For example, academic API, PDF processing, and storage. So for the database, we are using Postgres. We're also using RabbitMQ for asynchronous message queue, using Redis for storage, and B2 to store our PDF file. And for the academic API, we are using Archive, PubMD, Semantic Scholar, OpenAI, and a lot more. For the testing, you can basically test Spring Boot using Maven test and FastAPI using PyTest. And if you want to see our project, we already have the live. Our project is actually live on virtual machine. You can basically go to this link to see our project. Thank you.
In this part, I'll be showing Docker and the tests. All the Docker files for all repositories are contained in the Docker folder, and there are central scripts in the central folder for Docker and local tests and running. So first of all, let's run some tests. Uh, so this is the front-end test. I'll be running front-end unit tests, and let's also run the Spring tests. So as you can see, the tests are running. So while the tests are running, let me explain the Docker part. There are Docker app and Docker services for the Spring part. We explicitly different we explicitly kept different files for Docker services and our core Docker app. Uh, for the front end, there is also a Docker compose file and a Docker file. As you can see, the front end tests have all passed unit tests. Let's also run end-to-end tests. We have done an end-to-end test for login flow. So let's run this one first. As you can see, it passed. Now let's run a valid test. Okay, these two are the end-to-end tests. Now let's check the Spring test. As you can see, the Spring tests all have passed. Uh, we have built a Docker image for all our services and our apps. The Docker images are contained here. We also use Portainer extension to monitor our containers. Okay, that's all.
Assalamualaikum, I am Mitali. In this video, I will walk you through the infrastructure and deployment setup for our project, including the server configuration, deployment pipeline, and cloud setup. So in this infrastructure, we maintain 3 separate GitHub repositories for our project. So each one for our Spring Boot backend, one for our FastAPI server, and Next.js frontend. Every time we push to main, GitHub Actions builds the respective project and securely deploys the artifacts to our cloud VM using the SSH and private keys. So here, each workflow uses its own deploy script and runs independently. Like on the VM environment, variables are loaded from the local.env files, and each service is started on its respective port. Here we can see an example.env file that I have included here. So here now I will walk through the GitHub Actions workflow that automatically deploys our Next.js frontend to the virtual machine whenever we push to the main branch. So here is the GitHub workflow and GitHub Actions. Here, first of all, this workflow is triggered on every push to the main branch or auto manually through the GitHub interface using workflow dispatch. So here job deploy frontend, and it runs on the latest Ubuntu environment provided by GitHub. Then here, if describe the steps, then first step is first it sets up a secure SSH connection to the VM. It creates a .ssh folder, writes the private SSH key from GitHub secrets into the ID RSF file, applies the secure file permissions, and adds the VM's IP address to non-hosts. Then deploy frontend. So for deploying the frontend, it SSH into the virtual machine and runs deployment commands inside a hero block. So it navigates to the frontend project directory. Here is the directory. And the directory, and then it pulls the latest code from the GitHub repo. Then it installs the currently running frontend container using a Docker script. Next, it builds the updated frontend and restarts the app using Docker scripts. So this process ensures we always deploy the latest code with a clean rebuild. And the last step here is health check. So finally, it waits for a 30-second sleep and performs a health check by sending a request to the frontend at port 3000. So if the server responds, it confirms the frontend is alive. If not, it marks the deployment as failed. This GitHub Actions workflow automates our entire frontend deployment, from pulling the latest code to restarting services to verifying that everything is up and running, all with just a push of main. Now I can show that using a push to main. So here in the frontend, I will give a pair to the main branch from the staging branch. So if I create a pull request, staging pair for released, and here is taking the ability to merge. Yes, there's no conflict with the base branch, so I'm giving a merge request and confirming the merge. So the merge is complete. So now if I go to the main branch, I can see the GitHub action is running, or the workflow is here, setup job and setup SSH key done, and then it's running deploy frontend, and here is our workflow file. So it will take a long time. In that meantime, we can see the GitHub actions for our Spring and FastAPI server. So if I back, to the here, then here is the backend FastAPI. So here is also a GitHub workflow, and here this is also same as the front-end workflow. Here also same. It uses an SSH key to set up with the VM, then deploy the FastAPI server. It navigates to the FastAPI folder, and then it pulls the updated code, and then it uses a Docker script to stop the currently running Docker image. Then it stops any currently running frontend container. Then it builds the updated frontend and restarts the app using Docker script, and then a health check. And separately for our Spring, so here is our Spring Boot backend. So here also exists a GitHub action. This is also same as the FastAPI or Next.js backend. So now if I want to check the front-end GitHub actions, this is still running, so I am checking. Here is stating that the Docker image built successfully, and now its front-end deployment completed successfully. Now it's checking the health check. The health check also gets successful. So everything is okay, and the updated code has also been deployed. So in this way, our GitHub Actions workflow automates our entire deployment, from pulling the latest code to restarting services and to verifying that everything is up and running, all with just a peer-to-mail. So that's all from me about the deployment.